All right, so this aren't in my notes as a setup. This is a problem that I used previously in another year, and I thought it's not as difficult as it might seem, and there's sort of like a little trick that can be done. This is out of Myszka, I think. I think I'm pronouncing his name wrong. So we have a 10-yard dumpster that weighs 6,000 pounds right here. That guy. And the garbage truck shown has to be able to lift it. The load is shared equally by two forks, right? So we might as well start out by 3,000 pounds, and so that the other fork is on the other side, opposite side. So we want to determine the force in each of the two hydraulic cylinders, one that you can't see. Well, no, in each. Okay, no, I'm sorry. So I guess there would be four hydraulic cylinders, so we have to be careful. I'm sorry. And at each pin, be sure to draw all the free body diagrams properly and to scale. All right, so we want to try to figure out both of these, and there's some details right in here we have to be quite careful with. Kind of probably oversized drawings are worthwhile. So first off, let's do this piece right there. I'll draw over to the side so I can try to fit it all into one thing. And I think this is horizontal right there. I think so. So we'll go the FBD, declare it to be an FBD, and try to draw it as neatly as possible. Okay, so here we have to make a little detail right in there. Going to come down. There's going to be a spot right there. Come back up. And I think that's good right there. Okay. So we're going to have this little spot right there. Okay, so we don't have a lot of room. We'll make our 6,000, or excuse me, let's make 3,000. 3,000 pounds acting right there. All right, so our other spots. Okay, so we have at least one a two-force member. That's the hydraulic guy right there. So he's going to be up at an angle. I don't want to do that. So I should have made this thing a lot bigger. I should have exaggerated it maybe. So let's up this way right there. Oh, I don't like him. I want a green or something. What do I have going on there? I guess I have that. Let me go this direction. I go blue. Okay, so that right there. And did I label these things? I don't think I labeled them. That's a good. So we have to come up with our own numbering of things. So I decided that this was A. Let me put in green or something, so it stands out. All right, so this is A. These are what I was using before. A, B. I used F. I don't like that. F is a force, but I'll continue with it. So there's F right there, just so I don't get confused. This was D. This is E. And this is G to label the pins. So, and this is stupid to have that as F. A, B, C, D, E, F, G, H. That's H right there. Okay, I'll try to remember to put that out there correctly. So this is going to be FB. That's onto there. And then we're also going to have the forces of A. I'm going to use those as reactions. And because at A, like the piece that would be D, E, you could even call it H, A, that is not a two-force member. So we need to break this into pins up and down. So F, A, Y, and F, A, X. And we would really pretty much just only want those. Is that true? Maybe. Well, yeah, we'll see that we can eliminate those. So let's say we want to take the sum of the moments about A and balance it out right there. We have to figure out these distances, and we can see. So first off, we have a negative 3,000 because it's 3,000 is going clockwise about A. and its distance is 64. So that's easy enough. Now we're going to be a little careful with our pieces. So I will break this apart. We got to first maybe get that angle. I want to get I was looking for an angle that I call theta. So here's my angle of theta. Over to the side, I'll say theta is going to be equal to a little difficult right here, but we could look and see where H is. So we're going between B and H. And so we're going to say, and the height difference between them is going to be 68, right? Because we have 60 and 8. That is from B to 8 right here. So we're going to go the inverse tan of rise over run, and the rise, in this case, let's say that this 32 is the rise, right? So because we're going to try to put an angle right in there. So the rise is actually horizontal as far as we're concerned. 32 over 68. So we have an angle of 25.20 degrees. So continuing on with this, boom, we have a FB. Let's go in the let's go in the vertical direction. That's going to be counterclockwise. So FB, but only times the cosine of 25.20. All right. And then interestingly enough, the horizontal component of it is actually going to go clockwise. So minus, I forgot, and this is the mistake I make all the time. We need to have the moment arm. So the moment arm is going to be 18 for the vertical component, so 18 inches. And then minus FB times the sine of, oh man, I wish I had more room. Can I grab that? I don't know if I can grab it. Can I grab it, or is this going to pick it up? So, well, no, it would just, I can't grab it. Oh, I just want to move it over to the side. So 25.20. And now I need to put in its distance. It's only 8, right? So there's a, I kind of want to sketch it in, but I don't want to ruin my diagram right here. I will just put it in orange, right? We're taking a force, and notably it's going to go around counterclockwise for right here, right? So, and that distance is going to be 8 inches. So that's going to be times 8 equals 0. I did a terrible job of trying to squish that onto there. So anyway, we're able to find from that FB, and if I did the math correctly years ago, it's 14,910 pounds. Wow, that's a lot compared to it having to lift up the 3,000 pounds. It's a hydraulic cylinder, so it's pretty impressive. If you want to know the forces in the x direction at A, right, you can get the sum of the forces in the x direction equals 0. And then you can go FAX minus this guy, 14,910 times the sine of 25.20, and then there's nothing else, right? So you can get FAX equal to 6,346 pounds. And they can do the same thing in the y direction. And you go FAY, and I usually just assume that we're going in the positive direction and then find out whether we get a negative at the end and see if we're wrong. Should I do this thing correctly? Yeah, I did. Okay. So I'm going to go plus 14,910 times the cosine of 25.20. And then you're going to go minus 3,000 equals 0. And find out that FAY, how are you doing here? What we do? We got negative 10,490. But running out of room, if we wanted to know what the pin has to be, what the pin has to be able to survive, we would want to find FA is equal to the square root of 6,346 squared plus 10,490 squared, and we'd find out that we have 12,260 pounds, and that would be how much the pin would have to survive. So here becomes the next part of it is sort of a trick, right? Because we want to do the other cylinder. So you might think that we would want to, okay, put all these forces on, you might think that we would want to draw, let me highlight this guy right here. You might think we're gonna do this thing right there, right? And then start more, and then we have to figure out what H was, and then we have to figure out what E was. Well, H we could get from the other end of this two-force member, but we might want to try to get E if we took the sum of the moments about D. Yeah. You can actually do a trick and combine a bunch of things together. So let's see, I'll move my little finger here. So we could draw this thing out. I don't mean to be, whoops, that would be a terrible highlighter. A pen. And so let me make that black. And I'll try to draw this thing correctly here. This right here, up, over, and then down. Right? And now I'm including the part into there like that. And I won't bother trying to draw this thing out except to be like that right there. Okay, so that's not a great drawing of this, but it does work. So what we do is we'll have a reaction of D, F dy, F dx, and we'll have the main thing that we want, but this is a two-force member, right? Boom. So we'll draw this up to E, and we're certain it's probably got to be like there. Actually, it could be the other direction. I think actually it might be the other direction. We'll be lifting this. That's awkward. So we have FE, and we don't have to put anything else into there except for this guy, 3,000. Let's see, things to geometry to work out beforehand. Let's try to get that guy, and I will call him beta. That's supposed to be a beta, and we could find beta from, let's see, where did I go? What happened to beta? Where'd you go, beta? I want 18, the inverse tan. So I said that I don't have a good place for this. Beta is equal for the inverse tan of rise over run here. The rise is 18. The run is 72. And let me just double check that makes sense. Yeah, because we're looking at the difference between E and what we call G right in there. And so that's just going to be inverse 10 of that ends up being 14.04 degrees. Okay, so when we go to do our sum of the moments about D, we would first, let's see, what's the, so negative 3,000. And the distances, we're going to go, looks like it's going to be 64 plus 120 minus 10. 64 plus 120 minus 10, right? And then we're going to have to break down FE into components. And so, I forgot parentheses right there. It is probably, for the most part, like the main part of this is the FE that is going in the horizontal direction, so the cosine of 14.04, and the distance of that one is going to be 18 inches. Right here, 18 inches, because we have a force that's coming that way. There's the perpendicular distance. For the vertical distance, boom, that too is going, it's going to be coming upwards right here. And that's going to be, this going to be, the moment number is going to be the 10 right there. So we're going to, that is also going to be counterclockwise. So FE times the sine of 14.04 and times a 10 equals 0. So we can find out that the FE, the force in the hydraulic lift, is going to end up being, where'd you go? FE, 27,000. 27,760 pounds. And anything else we want to try to find? We can try to start finding what the force in D is going to be. I'm going to cut the video, stop the video now. So just so you know that FD comes out to around 27,000 pounds as well. Of course, E is 27,760. How much is in it? At B, I think. Oh, we already found that. We didn't find it. Do we need to find it? I guess that's pretty much all the spots that we want to find out. The only one left is really D. But if you work through there, we do find that we have pretty close to 27,190 is the answer. So this is one that's a lot like the problems that you have where it's going to be a hydraulic type of crane or I guess a piece of equipment with hydraulic stuff on it, like a loader or a backhoe type of thing. So hopefully this will be helpful. Cheers.